You're gonna have homework today about this, and should be the easy part. But block day, I don't know which day is block day for it's Friday. Okay, so that day, make sure everybody show up, and make sure that um, you understand all the things before we get there, because we have to understand area before we go to volume. Volume will be the hardest thing that you're gonna learn in calculus for 90% of you guys. For 10% of you guys, it's gonna be very intuitive. You look at it, you get it, and it's gonna make sense. For 90% of you guys, so you're gonna look at it, I have no idea what you're doing. So, but not to saying like discourage you. You just have to make sure that you're very attentive on those lessons, because you have any question, I'll try to make the best lesson. I've been teaching the same subject for like 8-10 years, and each year I modify something. Hopefully this year is the year I can explain the first time everybody understand. Usually need to read 3 times. Okay, so let's just say if I want to find the area between the curve. Okay, so imagine that I have area here. And this area will start with a purple line. So the purple line go like this. And we also have a black line right below. And we also have a cutoff between here and here. And I say I want to find the area of this region. I'm interested about this. The best thing is, how do I find the area just between here? What would you suggest? Yes. Does that make sense? So imagine that if you find the area of purple line, that this is the area that we find, right? That's first thing we find. And then we find the second one, the black line, which is the white part. So that means the whole thing take away the white, that becomes shaded region. And that work, even the graph is like below as well, like something like this. Top minus bottom still work, because minus negative becomes positive. It still would have worked, even though, so it's being consistent. Just make sure area between the curve is equal to integration from a to b of f of x minus g of x. But we have to define that f of x has to be greater than g of x at that time. So I'm going to say this is f of x, and the black line is g of x. And f of x has to be greater than g of x at the moment, because if you do it the other way, it's going to be negative. If g of x is larger, subtract each other, your area end up to be negative. I just want to make sure that you understand that f of x is on the top, g of x is on the bottom, because we didn't define that at the very beginning. So make sure it's always top minus bottom. Is that okay? You can have a second situation. Sometimes, because the way you calculate area is the way you accumulate area is like this way. You're basically adding the difference of the lines, and integral just basically adding all the lines together with a summation. And so this is called a vertical orientations. You can calculate the lines from the left side to the right side, and you can accumulate area that way. However, sometimes you're going to get a situation where later on we're going to give you a situation like this. The function is not a normal function, so sometimes we can get like something like this, and there's a graph like this, and there's a point here, there's a point C to D, But the way we cannot do area of top minus bottom, the reason being is if you do top minus bottom, this will work all the way to this moment. Why it work? Because you have the green function, the black function, they subtract each other. But this region here, wait, they are the same function. They subtract each other, end up being 0 because they are the same function. So you cannot do it this way. Not like you can. There's a specific way to do it. It's a lot harder to do because this becomes the area of interest that you, because the same function top minus bottom. Imagine top is function is the same as a bottom function. If they subtract each other, they'll go 0. So, but there's an algebra way to get around it. It's actually minus negative of that function. That becomes 2 times that function, but that gets kind of hard for a lot of students to see. So it's much easier to do a horizontal orientation. So the way that we can do is we can calculate area from the bottom going up and adding each individual slice. And this is a horizontal perspective. If a horizontal perspective, then it's going to be integration from C to D. It's not A to B. It's different boundary this time. C to D. We're going to assign this one is the f of x, and this one is g of x. And we're going to say f of x minus g of x. And you're going to be like, well, how do I tell? Usually it's right minus left. Usually it's right function, the black function in that interval. In between C to D, the black line is the right. And the green line is the left. Is that confusing? Yes? Why is it right minus left? Because if you really think about it, just think of in terms of top and minus bottom, right? You can tilt your head 90 degrees to the right. If you tilt your head 90 degrees to the right, it's a black function on the top. Yeah, so it's right minus left. Same way because we calculate the difference. The difference with the bigger value subtract the smaller value. The bigger value is more to the right. The smaller value is more to the left. So it's right minus left. So this is a different type of orientation. But does this happen all the time? Not as often as the X orientation, but it does happen. Now, we're going to learn also sketch the graph. So here is the question says y equal to x squared plus 2. And g of x is equal to negative x. And then x equal to 0, x equal to 1. Can you graph this bounded region? And also, can you attempt to find the area? How many of you guys know how to graph x squared plus 2? Gia?
You would draw the parabola and move it up.
So vertex is at where? Good. That's really good. So I'm going to go by what you say. So this is the graph. And then we're going to use scale of 2. 2 is 1. So that's going to be, this is a 1, this is a 2, this is a 3, this is a 4, this is a 5. And this is a 6. And since it's 2 units here, now usually parabola is going to go right 1, up 1. So this is up 1 like this. Right 2, up 4. So it's going to be like this. And the other way is the same way. You need to know the basic graph like this, the parabola, and square root. Square root is the sideway, so this is like this. So this is the purple graph. Well, it's supposed to be purple. Let me change to purple. And then green part of the graph is going to be what? Negative x. How do I graph negative x? Negative slope like this, right? Is this okay so far? We're going to cut off by 2 black line here because this is actually a the boundary. So we're gonna use this, like to strict that. So we are calculating the area from left to right. So we are doing like this. We start calculating and adding all the things. Therefore, my integral is what? From where to where? Why is it -1? From where to where? 0 to 1, good. What is the top function? What? X squared plus 2? Guys, please put a parenthesis. I cannot repeat that. I have so many people fail the test because of parentheses. Plus 2, thank you. And minus the negative x dx. Now just evaluate. You guys should know how to plug in the upper bound, subtract the lower bound, right? Can you do that for me here? And I'll get ready for the next questions. You get 17/6. And we just find out area from here to here.
Just plug in 1 for that.
Yeah, because I plug in 0, it's going to subtract off. 0 is gone. Is this okay? Now I'm going to do the second one. F of x equal to 2 minus x squared. G of x equal to x. So let's sketch this graph first. What's 2 minus x squared graph look like? Good. So it's have vertex at 0, 2. And upside down is like this. And this is the other way. Actually, I'm gonna probably have to move a little bit. Is that okay? And g of x is going to be x, so it's going to be here. And I can figure out here. Now, you have two things. One parabola, one lines. SAT always asks that, how many solutions are they? You can have maximum 2 intersections. Sometimes you can have 1, sometimes you can have none, depending on where the line places it. So how do I find the intersection? Mathematically. We know it's at -2 and 1, but how do I find it mathematically? Set equation equal to each other. Set f of x is equal to g of x to find intersections, right? So imagine that you don't know how to graph correctly. So that's going to be 2 minus x squared is equal to x. And then usually prefer the x squared to be on the side is positive, so I'm gonna move everything to the right side. So it'll be x squared plus x minus 2 equal to 0. I solve for it. X plus 2 is equal to 0, x equal to negative 2, x minus 1 equal to 0, x equal to 1. Is that okay? So now I know my boundary between negative 2 to 1. Is this okay? Because that's where they intersect. And that's when you start calculating area here. So the top function is 2 minus x squared. Minus the bottom function is the x. Make sure you put a parenthesis. Like I said, parenthesis is your key. Now, between today's homework and next week's this whole week's homework, what I want you to do, very important, pay attention. You're supposed to evaluate this by hand. However, I will not evaluate by hand first because usually I'll give you answers. You can check whether your answer is correct. So use decimal. You set up first, you calculate first using decimals. Make sure your setup is correctly before I do the evaluation, because only if I make sure my answer is correct, that means your setup is correct. If your setup is wrong, then your answer is be wrong. Then you go back to modify the setup, because what happened is you do calculation on the wrong setup, you waste 5-10 minutes, you waste a lot of your time, end up you have to redo everything again, which is you lose more time. So if I were you, on this next week, 2 weeks homework, it's going to be really difficult. You just have to make sure you set up first, evaluate the calculator, match the answer, see if it's matching. If it's matching, then you execution on the calculations. Because you just still have to train in calculation, but just not the priority. Priority, I want you to set up first before you do that. Yes?
Would this be like an FRQ for like the
It could be anything. FRQ, MCQ, it could be anything. It used to be really emphasized. It used to be every year there's FRQ. It seems like they start walking away from it, but it doesn't mean they won't come back. So now I'm going to integration this. So it'll be 2 minus x squared minus x dx between negative 2 to 1. And I'll show you how to do a quick calculation that inside my head is much faster. So it'll be 2x minus x cubed over 3 minus x squared over 2 between 1 and negative 2. And that looks kind of scary. But if you write the things organizedly, it's really hard to mess up. So it'll be 2 minus 1/3 minus 1/2. Is that okay? Minus, now I'm going to plug in negative 2, so it's negative 4. Negative 8, so it'll be positive 8 over 3. Does that make sense? Because negative 2 to the third is negative 8. Negative 8 times negative positive. And this one's negative 2 squared, so it's 4. So it's plus, that's minus 4 over 2. Now, I will show you a trick that I usually do. I don't like combined fraction too much. I'm not a big fan of combined fraction because I know how much you guys not good at fraction. But I try to play a trick. This 2 and negative 4. So, but this is minus sign. I'll distribute it first. So 2 plus negative 4, 2 minus negative 4 is 6. Is that okay? Now pay attention to the second part. This part and this part. It's going to be what? Negative 3, actually. Because the negative 1 minus 8 over 3 is negative 9 over 3 is minus 3. See, I don't have to add in fraction too much. And the 1/2 plus 2. So 1/2 plus 2 is going to be plus 3 over 2, right? So that's equal to 3 plus 3 over 2, which is 4.5. So I don't have to combine fraction too much if I can combine because usually they have a same denominator. They can subtract and adding, and sometimes they work out a really nice number. Or you can minimize adding and subtracting combined fraction. I think that's the key. I'm trying to show you the tricks. And that's the way I do it, but I don't know. It's up to you. You can do whatever you want. You can do combined fraction however you like. I just think about the calculation slightly easier. Yes?
Do you do upper bound minus lower bound, right? Like for the second.
Yeah, always upper subtract lower. That's FTC. That's general fundamental theorem of calculus at, yeah. Now I'm going to show you the horizontal calculations, horizontal orientation. Now the problem is this graph. The people don't know how this graph works. X equal to 3 minus y squared. By the way, this is not a function, but you still can do it. A function means you'll fail vertical line test. This will fail vertical line test for sure. But so is circle, but you still can find the area in the circle, so it doesn't matter. A function or not a function doesn't matter. Does anybody know how to graph x equal to 3 minus y squared? What? What would that graph look like? Okay, how about I have to think it a little slightly easier. Do you guys know what x equal to y squared look like? Instead of y equal to x squared. X equal to y squared. No, it's a little bit more than that. Those of you guys didn't know, it's a sideway problem. So y equal to x squared, it looks like this. X equal to y squared, it looks like this. However, y equal to square root x looks like this, just only in the top. So this is y equal to square root x. This x equal to y squared. This is y equal to x squared. Does that make sense? So that means I have y squared is facing, the parabola is facing which direction? Which way? Left or right? Left is correct. I'm sorry, I didn't hear you. Okay, but it's also go up 3 though. Go right 3, not go up 3. Because the vertex is using y perspective. So they go right 3 rather than up 3. So this is sideway parabola looks like this. So this is like this. Now some people say, how do I graph x equal to y plus 1? Or if you don't know, move the 1 to the other side. It's just a normal line. So that's going to be from here. And that's going to go in like this. And you're like, oh, okay, how do I find the area between? Now, this is the one is right minus left. Why? Because you cannot do it vertically. If you do it vertically, you can do top minus bottom, the red minus. This seems fine, right? It seems like black minus red is perfect all the way to this moment. So what you can do in this particular case, I'm going to do right minus left. But you have to be a boundary from -2 to 1. So -2 to 1. And then it's right minus left, so it'll be 3 minus y squared. I'm almost done. Minus y plus 1 dy. And if you evaluate this, you're going to get exactly the same as 902. But that's how you evaluate it. It's right minus left. But if you do it vertically, you're going to have obstruction between 2 to 3 because they are the same function. Do you see this part? They both red. Top minus bottom, they're going to cancel out each other. So you cannot do that particular section. You can, but it's kind of tricky. I can do it, but I don't want you to get involved with that. I'd rather you think about horizontal sensation, horizontal perspective. What? No, you set them equal to each other to be 3 minus y squared. Raj, you finished. You failed the last test.
What's that bad?
It was that bad.
Yeah, are you dead ass? Yeah, I graded it. Where is it here?
That's why you need to show up to school, sir. Your senior writers kick you in. You're worse than
No boy.
you're worse than the Indian boy last year. What's that Indian boy last year? Bob, yeah.
Failed like yes, you failed. It was that. I think you got a 20%. Are you dead ass? Oh, funny God, bro. God.
That's you have to resend that application.
God.
Give it to Benson. Give it to Benson.
Please.
Give it to Benson and Sophia. Vincent needed more than you do, Raj. You gonna stay here, old boy?
I love this spot.
Yeah, teach him MBA. Arabic MBA. Let me go to 100 on this test.
Did you even watch a video yesterday I record for you?
Yeah, I did. I did all the homework too. You good, bro? Oh,
So Chip, you okay?
Wait, what? No.
I was the
But I do it so often that I don't even know.
That's a problem. Right.
I'm not gonna go to bed.
Among your many others.
I don't see it.
What? No, you cannot.
You said I could. I messaged. Then I can take you again. Me and I both have. Maybe I'll get mine. For me, yeah. No, sorry. The timing was great. He didn't do anything. What? An hour like what? Yeah, I was with a Nathan's body. No, it wasn't Vincent. I saw the name. I saw the name. Nah, man. Why did Mr. Buell do that seriously? You never know. I was so telling that. Oh, I know he's serious. Well, I know. Wait, what? Look at how it's dragging.
Alright, so do your homework out.
No, like if I put the right, what's the right? When you integrate something,
He's gonna be a teacher. He's not even. He's gonna be Mr. Ye, Brian.
Wait, this Ye is a child for divinity or a child? I say divinity. Like the flow, I'm doing like I was thinking of like where like it's like plastic full of
even more than that.
Yeah, I'm gonna do that.
thinking of wearing like what do you do?
No, I'm gonna put that on the board. I'm gonna write.
And then after you do that, you see again. I don't. Bro, you never. But like, maybe different times.
All right, I might airdrop the homework answer to you. If you need answers, I may airdrop you the answers.
It was like 5 questions. Yeah, but I was doing shit all the time. The car is the light happens. You can do anything about the light.
I don't know who Sigma is.
Hey, 64 was right? So it's like grouping Taylor series type.
No, you find out derivative itself still itself. That's only function that does that. Or integration will exact the same function as scope.
Like when you write the overall thing, does it matter that your term is shifting? That you have to like start the end with 2 or?
That doesn't matter that much. Because you write out the terms still exactly the same.
Oh, yeah, no, it's not even your R is born, you never get it's not your Bro, yeah, technically I want to learn about myself. Like, I'm starting to think like not how many things
Oh, you done?
Well, we have like, do you want to pass it out?
Thank you.
Yeah. Lamar.
I thought you wanted to. Alright, out of these categories, which one you want to assign yourself to? Like, what would you change? No, but I'm trying to. Why is your iPad? I asked him. He said like they didn't know.
I proved the version, but taking version. I have to see.
Yeah, but I'm getting like, okay. Oh my god, I feel like someone they want like.
I got a 45, 46. Why you draw? Yeah, because I didn't see it. Yes. Point five. Wait, please tell me he's in A, bro.
That one's that missing.
Boy, I think the focus. Because I mean, I clicked on that page. Oh wait, did I not get yeah, I need to it's from yeah, most of them are over. Well, what does this mean?
Conditional.
I'm not wait. Yeah, we do. This one, I literally got it. I clicked short. I could see instead of.
That test doesn't look too good.
What?
I said that test didn't look too good.
I mean,
Yeah, I
think it's like I wanted to see.
You have to do it. I can't tell you.
That's so easy. Or oh yeah. How about you look at the graph there? How does this converge to zero?
So if I didn't actually write AST, but I did all
Yeah, you have to write down. You have to say something that based on price, which kind of
I
test.
did the conditions, but I have to actually write
Yes. Otherwise, I still don't know. I mean, I see that, but I need to see. We give you a point for you just negative sign. Try to think about infinity over infinity does not equal to zero. Not all the time.
Did you scratch this out? Did Christian write most of them scratched out, or did you?
I didn't write.
I can only faintly make out dumb. I'm not saying they're wrong, but you know,
I feel bad for you, so I erased it for you.
no. Wait, what did it say? What did it say?
Something about dumb.
I don't know. You know, I was like, on this one, I just remember that this was.
Yeah.
I realized that was the question, but then as soon as I got to that, I think I just read it.
Yeah.
And I just thought it was.
Okay, I see that. Okay, I'll met you in the middle. I'll go with 30. I see that, okay. But you still have to write out the test.
Oh my god.
All right, so
Okay, the motherfucking.
Can I do this? I can factor out the root. Like if I just put this back in,
so it should be, if you put should be back in, it should be N4.
yeah.
See that?
Yeah, it must be in.
Yeah, that's valid. Let me double check that. I got 7
You didn't need to get to 40. You need to show as it is, and
He gave you 7 X's. I didn't see anything here, but you wrote something else. I think you have to get more. Yo, Christian. Absolutely.
I think I had to relook at it too. No, I printed it, but I think I had to look at it too. And then you know, you can't change the
9 times.
Remember when I said about the that's the 3x. Here, it is this in the border. So you go from 212 to 5 out of 12. 12 out of 46 to 15 out of 46. Where you beat Ryan? What? Oh, you beat this?
I can sleep for the whole day.
Team 2. I should have went to that.
Oh, don't do that.
Yeah.
No, I still beat you.
He did beat me.
Damn.
I never did the version.
I like 330.
This wasn't
I miss only 50 minutes. Greatest line of the ever.
I tried using so if I were just like first. Oh, wait. So,
How do you do the final part? Yo, look at this. Yo, look.
Which function looks like that? They want you to think about that. Which function that you take a derivative is still gonna be original function.
go up to school, bro. What are you You still have to. You still have to do like Oh, probably did.
Yeah, me too.
Yeah, I got the power. Oh, the This is your baby. This is always going to be free is your delta x. Well, you get the delta x such that delta x is
What's change? All right, that's cool. You maybe just like ignore everything else. That's zero, right? And what's changing every time you go to no, every time you go to a turn, like there's something that's changed like every I just oh yeah, right? And then the one thing I didn't do this before. I'm so
All right, so
function looks like that. You take the derivative. I mean, you take the derivative of it, and it becomes like the negative of the other one. What function?
63, yeah.
Well, you can do like or you could change by taking that's why.
All right, so so for 33, so for 33, like if you write out the things, it's gonna be look like this. So I hear that just means times 1, right? So for this particular part here is what? M plus 1 factorial over m factorial. So m plus 1 factorial means m plus 1 times m factorial over m factorial, and that's how you cancel out. And then you do ratio test after that. And then you should get the answer that you're supposed to get. So it just recognizes that this is 1 times 2 times 3 times 4 times all the way to m plus 1. So if that's the case, it's m plus 1 factorial. If it's m plus 1 factorial, then it's going to be m plus 1 times m factorial. So m factorial can cancel out on the bottom of the m factorial. This 2 can cancel out. Eventually be m plus 1 times x to the n. And summation of n equal to 1 infinity. And then you can finish there. For 63, if you just do ratio tests, so 63, do you guys have a question about convergency, interval convergency, or show that f prime of x equal to g of x, or f prime of x equal to negative f of x, or identify the function f of g? Which one do you guys have? Identify the function. Okay, so that we're gonna get to that today, but that basically, if you look at B, which one that derivative is gonna give you g of x? So think about any function that you can take a derivative, and it's gonna be the g of x. So if I take a derivative f prime of x equal to g of x, and what the second condition is, what if I take a g prime of x equal to negative f of x? There's only one type of function that does that, changing sign after you take a derivative, and it's very similar. It's trig, right? Because you take a derivative of the sign, it's equal to cosine. So the derivative, so f prime of x, so we want to make sure that f prime of x, which is that ugly function, is equal to g of x. So which function that you take a derivative is going to be g of x, and then if I take a g prime of x equal to negative f of x. So which kind of situation? Now we can probably just assume is some type of things that can cause changing sign. After first derivative did not change in sign, after the second derivative is changing sign. So if you start with a cosine, the first derivative is changing sign. It's become a negative sign. Does that make sense? And so if you say, well, assume that f of x is equal to sine of x, if you take a derivative, is equal to cosine of x. And if you derivative again, is equal to negative sine of x. And this is the only one that's a whole true. So in the same logic that you're going to use for 63, you're going to use for 64 as well. Which function that you take a derivative is going to become f prime of x equal to f of x. That can only happen one function in terms of all the function, transcendental function that we have studied. And that has to be e to the x. So it turns out this is the correct power series of the sine and x and cosine of x. Now, today, we are going to figure out why that is. We are going to figure out why that is. Yes.
Will questions mainly ask for those three functions, sine, cosine, and e to the x, or will they include just like x squared or random functions like that as well?
That is a great question. The most common AP exam question that they always referring, that the one of the power series you have to remember are sine of x, cosine of x, e to the x, 1 over 1 minus x. Yeah. And we're going to talk about the derivation of, we can talk about, so let me write it down. Sine of x that you had to memorize. Let me write down all the power series you need to know. That way you don't completely throw out. But we're also going to talk about how we get them from whatever we know. So I'm going to say sine of x is probably the most important one. It's negative 1 to the n, x to the 2n minus 1 over 2n plus 1. This is plus 1 to the factorial. If I can take a derivative, right? Just imagine that if I take a derivative of this function, that if I take a derivative of 2n minus 1, the power rule, what it's going to be? What's going to drop in the front? No, 2n plus 1 is going to drop in the front. So think of if I take a derivative of this, right? So it'll be 2n plus 1, right? X to the 2n, right? Over 2n plus 1 times 2n factorial. And this is negative 1 to the n. Does that make sense? This cancel out. What does that look like? X to the 2n over 2n factorial, negative 1 to n. So cosine of x is equal to negative 1 to the n of x to the 2n over 2n factorial.
So for the bottom, it doesn't change?
So like, how can you take the derivative of the top of that to the bottom?
That's just a number. The only x is changing. Only in x is a variable. Everything else is constant. N is always constant.
So you're not taking the derivative of anything except for x. You can do that?
Yeah, because everything else is constant. If I can take a, remember we have natural log of
okay, because you take it outside.
x over natural log of 5, like 2. We don't really take care of anything else, like 2 over natural log of 5. It doesn't really matter. We just take a derivative of natural log of x. And 2 over natural log of 5, it just multiply at the end. So that's the same thing.
And then for the negative 1 to the n, you can just kind of keep that no matter
Yeah,
what.
because that still stay there.
So, okay, that's technically a constant, even though.
So the cosine is the derivative.
Yeah, that's what we learned before. Yay! Yeah, that's what we learned before. That's just what's the cool part is this. What the cool part is the series work exactly the same way. You can actually take integral of this, and you're gonna get the same thing, which is that's pretty cool as well, right? If I take an integral of, let's say, if I take an integral of this, right? What would it be? Like these are things that you can think about integration to cosine equal to sine. But if I take an integral of this, that's going to be 2n plus 1 times 2n plus over 2n plus 1. Then that's where the 2n plus 1 shows up. and that they work exact same way. Lyndon, that first question is really bad. You cannot make this algebra mistake. You too often make this algebra mistake. That algebra mistake is kind of like killing.
History, how did you know you could cosine x again? Like you said, it's alternating.
Yeah, so this is a question is inferring. Like a lot of time that you think about, after the first derivative and second derivative go back negative original function. The only function that we know does that is sine of x. The only function we know is not e to the x, it's not tangent of x, it's not, take a derivative of tangent of x is secant squared. Take a derivative of secant squared is 2 secant 10. So it doesn't go back to original function. The function that take a second derivative go back to original function is sine of x or cosine of x. But if you want a specific orientation, negative sign and positive sign, you had to start with a positive sine of x. It's logical reasoning. It's inferring question. This question is a little bit more difficult. It's inferring for you to see what situation it happens.
And then the way you can tell which is sine, which is cosine is by the power. Like even or odd.
Even and odd, that's what gives a good clue for Nathan. So that's why when first time he saw this function, he was sitting all the way on the other side. He's like, "Oh, that's a cosine of x because that's even function." Yeah, so those are a good indication of So that's good indication of even function because that's why sine of x is odd and cosine is even, right? That also very good is proof to what happened. Very good justification. Yes, Isabel.
Look like for
1 over 1 minus x? You already know. Think. Nobody should answer your question. You got to think. Which one is 1 over 1 minus x? We did it on the notes yesterday, 2 days ago.
just be like in geometry.
Yeah, geometric. It'll be x to the n. It's summation x to the n. So 1 plus x squared plus x to the third plus x to the fourth. And that's a very good thing that we've got to think about. But today we'll go back to talk about power series, right? Yesterday we talked about what we take Taylor and Maclaurin. So yesterday we finished it off with what is a to the n, right? So remember, okay, also we're going to talk about what's the difference between Taylor-Maclaurin series and Taylor polynomial. Polynomials stop at certain term, and Taylor series is just don't stop, just keep on going. So let's go back and review whatever things that we said yesterday. We said yesterday that we can take a derivative. We can take a derivative. So we start with I'm just going to kind of fast track of this. F of x equal to summation of n equal to 0, infinity a to the n times x minus c to the n. This is a general form to represent any type of power series. The key thing is, hey, do we know what a to the n? Can we come up with a general term for a to the n? But what Taylor suggests that says, well, we can take n derivative. So we start by writing down the first derivative was a to the first notation a0 plus a1 times x minus c plus a2 x minus c squared plus a3 x minus c to the third. If we can figure out this, how do we figure out? He proposed, so Taylor proposed, if I can take f to the n derivative. Okay, if I can take n derivative. If I'm just trying to find a general form of a to the n. So we list down the first few derivative. First derivative, a to the 0 is going to go away. And a1 becomes the main character. and there's 2a2 times x minus c to the 1, and plus 3a3 x minus c to the square. Does that make sense? And that becomes n a to the n times x minus c to the n minus 1. Is that okay? And this is what we kind of go through this at really end, so I just kind of want to, if I take a second derivative, what happened to a to the 1? It goes away. So what happened when the 1 drop in the front? So it'll be 2 times 1, right? A to the 2, right? Plus 3 times 2, a to the 3, right? Does that look familiar? Is that okay? And this is going to be what? N times m minus 1 to the a n x minus c to the n minus 2. So that's the second derivative. We're going to keep on taking 3 derivative. So you should see the pattern. This term is going to be a constant. It's going to go away. This 1's going to drop in the front. That becomes 3 factorial. A to the 3 plus n times m minus 1 times m minus 2 times a n to the x minus c to the n minus 3. Now, obviously, if I take the n derivative, because this is 3, right? So let's mark it as 3, and this is 3. So we know the first derivative is going to be n times m minus 1 times m minus 2, dot, 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 dot. Well, we know this sums up to be m factorial. But the last term is going to x to the n. So this is the third derivative, right? 3 minus 3. So it'll be x minus c to the n minus n. What is n minus n? Zero, right? And what's anything to the 0 power? 1. So it'll be n of x. This one's m factorial times a to the n. Then just basically little equation. We say what we're trying to go is to find out what a to the n is. And a to the n becomes fn to the x to the n factorial. So we just find a general form of that sequence. And this is what Taylor and Maclaurin says. So base this. Now, do you have to understand all this? I thought it was really cool. I never tried to explain this the year prior. And I had to try to understand them what's going on. Why do they do this? And I thought it's very interesting that a mathematician just say, hey, let's just take n derivative. Then we can find out what an expression of a to the n. And we can just insert that expression in. It becomes a way to finding any power series of any functions. Because we can generalize this happen. So let's talk about Taylor and Maclaurin. So Taylor series, hold on. Uh-oh. Yes. Hey, can I call you back in like 1 hour? Actually, I'm in the class right now. Okay, thank you. So a Taylor series is the main character here, and people says, "Oh my God, this looks really scary," but it's not. It's not scary. It's actually very simple to do. We're gonna start deducing those formula that we just found earlier. M factorial of x minus c to the n. So this is Taylor series. Now, Taylor series is the only difference between Taylor series. This is Taylor series. C is at x equal to c. Center at x equal to c. That's the Taylor series. Now, if you don't write out several term, it will look like this. Is f of c plus f prime of c, because that's the first derivative, times x minus c, plus f double prime of c times x minus c to the second. And then all over 2 factorial. This is 1 factorial. And just keep on writing. You just keep on writing. Okay? Now, what happened if you have Maclaurin? Maclaurin's a little bit lazier. Maclaurin, same thing. At 0, m factorial, and x to the n. So because Maclaurin is centered at x equal to 0. Because usually there's a minus c, right? But c is 0, so, and also this is 0. I like Maclaurin better. Yeah, fn of 0. So how many people is feel intimidated by this formula? No? Okay, so I'm gonna tell you like it's super easy. So remember yesterday, 63, we have an equation looks like something. Yeah, m factorial, thank you. So what we're gonna do is we're gonna say, hey, sine of x. Actually, I'll even use the even easier one. F of x equal to e to the x. What we're gonna do, we're gonna apply this formula. We're gonna apply this formula. M-A-C-A-L, no, M-A-C-L-A-U-R-I-N. Maclaurin, it's like the car, right? No? Oh, no? It's not a car? I thought it's a car. McLaren? Oh. I don't know. He worked with Isaac Newton, then Leibniz, Euler, Lagrange, Wallis, Fourier. All right. Okay, so for this is a very, very easy thing to do. You take a derivative. You take second derivative. You take a third derivative. You take the fourth derivative. And guess what? They all equal the same thing. E to the x. E to the x. E to the x. E to the x. Is that okay?
Yeah.
Okay, plug in f of 0. What's e to the 0? 1. F prime of 0. F double prime of 0. I guess you get a point. So now write down this series. So the series is Maclaurin is summation of n equal to 0 of infinity of f of n of 0 over m factorial times x to the n, which is that's equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x to the third over 3 factorial. Is that okay?
Wait, why can't we just
Well, we have to establish some pattern so we can write down general pattern.
That 5 factorial? Oh, pretty good. Yeah.
Because I want to center at 0. Yeah, Maclaurin. We only apply Maclaurin. Maclaurin says it's plug in 0.
And x is
So this is 1 plus x plus x squared over 2 factorial plus this is third. So x to the third over 3 factorial plus x to the 4 over 4 factorial dot 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 dot. Can you write a general term? N equal to 0 to infinity, what will be the general term of this? No. See, this is a 1. This is a x to the 1 over 1 factorial, right? What do you think? X to the what power? N factorial. So what it's saying is this is equal to, what it's saying is this equal to same representation as if f of x is equal to e to the x. So this means this. If it goes an infinite amount of time, that's going to look like that. Okay, so what you're supposed to is you're supposed to do ratio test of this. Can you do ratio test of this for me? You can say the radius convergence from where to where? Somebody answer that? What?
x over n plus 1, so negative infinity to positive infinity.
Yeah, so it'll be negative infinity to infinity, right? So ratio test. And hurry up. So that's equal to x to the n plus 1 over n plus 1 factorial times x to the n factorial. So we know that this cancel out, that's equal to x. And we know that n factorial is what? N factorial over n plus 1 times n factorial, cancel out, times x, 1. So if we go to limits as n approach infinity, 1 over n plus 1 times absolute value x, this is always going to go to 0. It doesn't matter what x is. So it'll be negative infinity to infinity. This is the same representation of e to the x. And you say, Mr. Ye, I don't believe you. I understand. I agree with you. You should not believe me until you see it. So if I type in e to the x, so f of x is equal to e to the x. And this is a function that we're trying to imitate. Right? And we say that's going to be summation of this n equal to 0 and I don't know, 5 of x to the n over what? Over n factorial What the hell is factorial? It looks like that. It's only into fifth though. Only into fifth. That means fifth degrees. Right? Now, imagine if I go to 10th degree. Imagine if I go to 1000 degree. I mean, they kind of break down after that. But, I mean, they didn't. They do fine, right?
Wait, so what happens if you
So what happened if I go to infinite, this is going to be exact same representation of that. And we can say this is equal to g. We can say that. Say, can we define this as g of x? G of x is equal to this, right? Wait, why do I need a slider for g? Huh?
You put it to the 10 million.
Oops. Wait, they still gonna slide? Doesn't matter. Oh no. Wait. Oh, it's not sliding anymore. Okay, so if you don't believe me, you can say, well, what we want to find a g of, I don't know, e of square. So e of 2 is undefined. That's the problem. I think it's broken. 7.28. Okay, that's 100 iteration, right? What is e to the square? That's pretty accurate. That's only if 100 degrees. Got it? So your goal is to figure out what is the representation of sine of x. Now you're going to derive this. Take a fourth derivative, find out general term, do a ratio test. Find a fourth derivative, a fifth derivative, find a pattern, write it down. We're going to prove 63 from yesterday.
Oh yeah, we do one. These are alternating.
Start with 0.
Oh, wait, no. Still funky. Well,
Mr. Yeah, did we
well,
send
we
her
already-
it?
we got pull up and pull up and this is Richard Kennedy. We just got it, right? Dude, figure out.
Oh shit. After we get even numbers, oh, you can plug it into this big function here, no? Or do you do? Okay. Bro, what? Like, yeah, it's just right. So it's zero.
Wait, are you talking about like within the series?
Over 1/4. Zero x squared.
Oh, no, no, no.
Negative 1.
I'm trying to figure out how we can have it so that alternates to zero, like a series of numbers.
Oh. How does this work? Because this is using.
What about zero to okay, so if it's zero to the end, then you can. That's
I guess so. Because they. Every even derivative is zero. Negative 1.
But you know how alternating series like negative 1 to the end,
How do you get rid of
and real there is negative, so we can do something like that with
where the pattern is here? Because that means every even number of n has to be zero.
Now write out general term once you have to figure out a pattern. If you figure out a pattern, write out general term. I'm gonna collect the test. I need a test back.
Every even number has to be zero. And then every third, every multiple of 3 is negative.
what are you talking about?
Right? So 3 is 9. Well, they're all nice. Every third derivative has to be from 3. Every even so now we know. And we know any factorial is 1.
Negative 1 to the end. Last time we found one This is like how is the spherical Tokamak fusion reactor different from a non-spherical Tokamak fusion reactor?
Could you do like negative 1 to the n?
Yeah, I think what you're doing is wait, what is it?
And cosine n.
I don't know how I need to like no, yes, constantly. Someone said food envelope.
So with these equations, you would have to memorize them.
Or you can derive them. Or you can derive them.
This one's good. Uniform circular.
But it's not hard to do. Ethan's asking a good question. So is those question that you just have to memorize it? Or you can derive them. So either way, I think memorizing slightly faster because it's just a function. So it'll be 2n plus 1 over 2n factorial. 2n plus 1 factorial. But is understand the general term. But you also need to understand that there's an easy way to memorize this. Remember, cosine start at 1. Cosine at 0 is start at 1. So it should be 1 plus x to 2 over 2 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial. It should be like all the even powers. And then if you think about sine of x, the sine of x at 0 is start at at x. Because if you look at the middle part of the region, so look at the middle part of the region, right? Look at the cosine graph. Cosine graph start at this. Start at a pick. It had to start, the first term has to be 1. The second one is sine graph. It had to start at x. And that's a probably easy way to think about it, because you start where the starting value is. I think that's would be slightly easier to think about, but it's up to you. I mean, for me, you have to know some basic thing. E to the x, sine of x, cosine of x. If you make an index card, it's not difficult to study a little bit before the test. But also know that cosine is even function, sine is odd function. E to the x is just the simple one, xn over n factorial. And also 1 over 1 minus x. Those are the 4 standard one. Now we're going to talk about how to use this to get other one. Because there's all other function that you can think of. How about arc10? Like, how do we get arc10 from here? Right? But it's all manipulation, algebra manipulation. Trust me, it's just algebra manipulation. So I'm going to go ahead and take a third derivative here. So first derivative is cosine of x. Second derivative is negative sine of x. Third derivative is going to be negative cosine of x. The fourth derivative is going to be sine of x. And the fifth derivative is equal to cosine of x. Okay, so f prime of 0 is what? F of 0 is what? 0, right? What's f prime of 0? 1. What's f double prime of 0? 0. What's f triple prime of 0? Negative 1. What's f fourth of 0? What's f5 of 0? 1. So let's write out. The first term is going to be 0, right? Plus 1x to the 1 factorial. Is that okay?
So which summation are we following though?
We follow Taylor series. We're using the Maclaurin. We use this. So we're gonna write down all this thing in the first 4 term. Is that okay? Like right here. F of 0 times plus f prime of 0 times x times f double prime of 0 x squared over 2 factorial f triple prime of 0 x cubed 3 factorial. So maybe I'll write it out again here. So let me write it out. This is summation of fn of 0 over n factorial times x to the n equal to 0 to 1 to the infinite. So in this case, what we're going to write down, the first term is 0 plus x1 over 1 factorial plus 0 times x squared over 2 factorial plus Huh?
Oh no.
No, this one's minus, you're right. So this one is going to be negative 1 x to the third over 3 factorial. Does that make sense? And plus 0 x to the fourth over 4 factorial. Minus plus minus. So this is a plus, sorry. So this one is going to be what? X to the fifth over 5 factorial. So you see that this is going to go to 0. So this is going to go away. This is going to go away.
So from this pattern, they got the series, like the power series.
Yeah. So if you see that the n equal to 0 here, infinity, the first thing is the positive, right? The first term I want to be positive, so that has to be n. Is that okay? Because that first term is 0. Negative 1 to the 0 is what? 1. So my first term is 1. And the x, well, it's 1. So, but how do I get 1 the first term, the third on the second term? So this is n equal to 0, n equal to 1 here. So if you're matching here, what happened? N equal to 1 is going to give me 3. N equal to 2 is going to give me 5. What would it be? 2n plus 1. Is that okay?
After you do it, you then have to build the equation.
Exactly. So then you will have the bottom is going to be 1 factorial, 3 factorial, 5 factorial. So that's going to be 2n plus 1 factorial. Does that look like something that we did before?
Yeah.
Which is sine of x.
Wait, so if I plug in 2, how do I get 0 on the bottom?
2 is going to be 5. 2 times 2 plus 1 is 5.
So what happens to the other ones? We can just cross them out if they're equal to 0.
Because we write down whatever base left in the pattern is. But this becomes your first term. This becomes your term. This is the first term. This second term. And we base that to write that my power series. Once I write out my power series, I can still write out like it's gonna be looking like x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial. Now, what's interesting is this. If this represents sine of x, right? And if I say, hey, I don't want this power series. I want something else. I want a sine of x squared. What happened? What?
Never mind.
It's not true.
If I want a sine of x squared, so I say I want to find Maclaurin series of a sine of x squared. So I just replace the x with what? Yeah. So it'd be x squared minus x squared to the third over 3 factorial plus x squared over 5th over 5 factorial minus x to the 2 to the 7 over 7 factorial. So this will becomes x squared minus x to the 6 over 3 factorial plus x to the 10 over 10 factorial minus x to the 17 over 7 factorial. So I can replace whatever x with something else. On the other side of the power series,
Wait,
it's just
why
a
is that
composite
factorial
function.
on the bottom because top becomes 10 factorial?
Oh, 5 factorial, you're right.
Misbehaving.
Mm-hmm.
So like, alright, is it possible to build like a Maclaurin tried it, but then you're gonna have to do the chain rule, and everything becomes 0.
Yeah, so it'd be much easier to have a sine of x and like. What's the difference between sine of x and sine of x squared? It just replace the x with the x squared.
Yeah.
But you can do that with power series. Because in that you have to deal with chain rule. That's a pain in the ass.
So basically, you can treat whatever is inside of the x as a u, and then you put it back in.
Yeah, so today I can say, hey, what is sine of square root x? Just plug in the x with the square root x on everything else. And you can even find the general pattern of this. And that's gonna be that's your power series of sine of x squared. So that's why you can build a power series on a lot of type of equation. There are some doesn't work with no remainder. There was no Taylor series remainder, but that we're gonna talk about later. But this is a situation that you can plug in any equation that is gonna be true, as well.
So how would that fit in with the summation writer? Would that
Then you have to write down what do we start here?
But you have to build a whole new one.
You have to build a whole new one based on this pattern.
okay? So you can't just plug it into the summation, but you can plug it into the output.
Yeah, so this one's n equal to 0, this one's n equal to 1, this is n equal to 2, and n equal to 3. Now,
So it-
what is gonna be this one? So you have to figure out what 0 you're gonna get 2, what 1 is gonna give you 4. And you can build that power series, and you can plug in, see if it's true. We can try to see if it's true.
2n plus 4.
X to the 2n plus 4. Do they alternate?
No, it doesn't.
It only works for n equals 1.
Oh,
But what if n equal to 2 here? Does it work?
4n plus, yeah, but it's
N equal to what?
4n plus 2.
4n plus 2? So 4n plus 2?
Oh, yeah, because it increases by 4 each.
But that's
Okay.
the same thing as putting it in the original function, though. Because if I put x squared in the other one,
Yeah. Actually, yeah, it is.
so you can just plug it back in the series.
Yeah. So what would it be? It's the first term is positive, so it'd be negative 1 to the n, right?
Yeah.
And over, what is the first? Here is n equal to 0.
Same on the bottom, so 2n.
So 0 factorial, n factorial.
No, 2n plus
2n plus 1.
Yeah, factorial. Because it's the same
like
thing.
You can't just plug it in.
Yes.
You wrote out the like your numbers for sine based on the power rule from before, from the sine x, or how do you?
So you know that this is sine of x. So instead of replacing x with the x, we're replacing the x with x squared.
So you just okay.
I just replaced that x, the composite function. Right? You can get cosine of square root x as well. So that's just how do you get from one side to the other side? Any questions? So we know sine of x. We can know sine of x squared now. We can even know sine of x cubed if you want to. Sine of square root x. It doesn't matter because I can replace the x with some other variables. Some other variable with a different power, right? So, so that is going to be very, very easy to generalize a lot of things. Now, not fully satisfied yet, but you can do something about different things now. Whereas, well, what if you have some other functions, right? What if you have some other situation? For example, f of x is equal to 4 over x plus 2. And center at 0.
No, it's not. Oh wait.
So
Oh. Well, it can also be geometric, right? Because it.
okay, so let's read it. Let's think about what Ethan says. 4 over x plus 2. It's not a trig functions. And do I really want to do like Taylor series about this? I feel like I can avoid them by, if we take a derivative, I think it's kind of hard to find a pattern. I think it's kind of hard to find a pattern, but there probably is pattern, but it's probably kind of hard. But if I can just think about geometric a little bit, the best friend of you're gonna have is 1 minus r, a over 1 minus r.
Mean that it would have to be negative x minus 1.
That means f of x, this one is must be 4 over 2 plus x. So I have to write an arrangement with numbers in the front, expressions in the back.
I know you take out the 4, but is it really good if you take out the 2 as well?
We know it's minus r, right?
Yeah.
So this is r right here. And then you say, okay, well, can r be, and it has to be minus. And so can I rewrite that as this way?
We just multiply by 2.
2 over, I can factor out a half. I can factor out a half. So, and once you factor out a half, it's going to cancel out. So the goal is to make this 1. How do I get a 1?
That's okay.
That becomes 1, right?
Yeah.
And I'm going to go with minus negative.
Then you can live with 1. Save me.
This is the algebra. Okay, if you don't believe me, let's just distribute it back, all right? So that's just 2 over 1 plus x over 2, right?
Yeah.
And by times 2 top and bottom, it's going to be 4 over 1 plus x, right? Does that make sense?
Yeah.
4. This is a 2. So that becomes, go back if I multiply 2 top and bottom.
Yeah.
So basically, I'm just trying to change that. It becomes 1 minus something.
Yeah.
Or 2 makes sense. Right. Like if you ended up writing it out, it would be negative 1 to the n times 2 times x over 2 to the n.
So if you write it out, so we're gonna say 4 over, I said x plus 2. I'm gonna write down as a power series. So this is the power series. Power series, geometric series is n equal to 0. Infinity a1 times r to the n. A1 times r to the n. What will be the n equal to 0? What will be a1 here? A1 here is 2, right? And what is r? It's negative x over 2 to the n.
And you could theoretically factor out the negative 1 to the n.
No, just leave it there.
Leave it like that.
Now you're gonna write out a term like this just means equal to 2 times, because I can take out a 2 outside, and that's gonna be if n equal to 0 is 1, minus n equal to 1 is what? X over 2 plus x2 over 4 plus x3 over 8 minus. So you can represent using power series like this.
R had to be a constant.
R doesn't have to be constant. R can be a variable. Yeah.
Because remember with the 1 minus.
Oh, you're right. Yeah, you're right.
So that's how you find the power series of this. But I didn't go through Taylor. Taylor will be something like easy: sine, cosine, e to the x, right? 1 over 1 minus x. Now we have it. Now we even have 4 over x plus 2. It looks like geometric.
For this, the radius would end up being like 1/4 or something like that, right?
Radius is going to be 2. But interval convergence is going to be -2 to 2. You have to work it out. Negative x over 2 has to be less than 1. And you work it out, it's going to be between 2 to 2. Geometric, but this one just gonna be the question gonna start with a center at 0. If I don't tell you if a center as something else, then it's gonna be something else. Sometimes I'm gonna tell you center as something else.
We can only use like 1 minus center at 0, right?
Theta will be center at C.
Because basically, instead of having yeah, but then you're treating it.
How much time I have? I have a lot of time.
But why did you do this? Oh,
It's like 1 was faster.
but look at negative 3 to not.
Bro, it's study, bro. No gym, man. I'm locked in. No gym, bro. I know. I'm study, bro. What's the point of this? Wait, bro. You're actually so hard. I just know you have to go on and take off. I forgot, bro. Did you even know you could put extra? Yes. God damn it. I get the first time.
Uh-huh. I should play ping pong. All right, I'm gonna start giving you some work, and you can start working on it.